Welcome to the Explainer. Okay, today we are diving into something absolutely mind-bending. Have you ever stopped to wonder how human brains, or even computers for that matter, actually generate meaning? I mean, we intuitively feel like we understand the world around us, but when you look closely at the mechanics of cognition, things get incredibly mysterious very quickly.
Think about this for a second. How does a physical system, whether we're talking about a biological brain locked inside a dark skull or a silicon chip trapped in a metal box, how does it ever truly understand a word? It's kind of the ultimate paradox, right? Philosophers have been pulling their hair out over this for decades. Okay, let's dive into this and see if we can unravel the mystery of semantic understanding.
Here is our roadmap for today. We'll start with the Chinese room paradox, move to the water pump breakthrough, look at partitioning the mind, explore meaning from syntax, and finally wrap up with escaping the room.
Section 1. The Chinese room paradox.
So, back in 1980, philosopher John Searle came up with this brilliant thought experiment called the Chinese room. Picture this. You're sitting in a completely closed room with a massive rulebook. People keep slipping pieces of paper with Chinese characters under the door. Now, you don't speak a word of Chinese. You literally just look at the shapes, flip through your English rulebook to find the matching shapes, and slide a new piece of paper back out. To anyone standing on the outside, it looks like the room speaks fluent Chinese, but inside, you understand absolutely nothing. Searle used this to argue that this is exactly what a computer does. It just shuffles formal syntactic rules around, but it has zero genuine semantic understanding of what those symbols actually mean.
But what if I told you that one of the most brilliant minds of the 20th century actually grew up inside a literal, physical equivalent of the Chinese room? I'm talking about Helen Keller. As a deafblind child, she received only formal, meaningless, tactile sequences spelled into the palm of her hand by her teacher. There were no visual contexts, no auditory clues, just uninterpreted, tactile syntax. She was quite literally locked inside her own dark, silent room, which kind of makes her the ultimate real-world test case for Searle's paradox.
Section 2. The water pump breakthrough.
Everything changed at a water pump in Alabama. Her teacher was pumping cold water over one of Helen's hands while over and over again spelling the letters W-A-T-E-R into the other. And then, suddenly, it just clicked. The philosopher Walker Percy perfectly captured this. He said, before, Helen had behaved like a good responding organism. Afterward, she acted like a rejoicing, symbol-mongering human. I mean, in a matter of hours, she went from just reacting to stimuli to experiencing true human comprehension. But what actually happened inside her brain to trigger that flip?
Well, this breakthrough was basically what we'd call an information-theoretic quantization. Now, I know that sounds like a massive mouthful, but let's break it down. Look at the stark contrast here. Before the well house, her experience of the world was just a continuous, high-entropy analog sensory stream, basically messy reality. But after the well house, she quantized that raw physical sensation into a discrete, finite-state syntactic string, the actual letters W-A-T-E-R. She essentially took the chaotic, analog universe and chopped it down into strict, manageable digital blocks.
Section 3. Partitioning the mind.
Now, what's really interesting about this slide is how we can explain this computationally. Computer scientist William Rappaport uses a knowledge representation system known as SNEPs. Rappaport argues something pretty radical. The mind doesn't generate meaning by looking out a window at the external world. Actually, scratch that. It operates entirely as a closed network of structurally linked concepts. What Helen Keller did was essentially construct a network exactly like this one, right inside her own mind.
We usually summarize Keller's epiphany at the pump as her realizing that everything has a name, but computationally speaking, this was a massive rewiring of her brain's architecture. She literally partitioned her mental concepts into distinct computational nodes. She created one set of nodes just for words, the finger spellings. Then she created a completely separate set of nodes for physical objects, like the actual water splashing on her hand. And the real magic? She established a totally new class of relations, naming relations, to connect them together.
If you look at the diagram here, you'll see Keller didn't just learn a single vocabulary word. She actually generated a totally new metalinguistic node for the very concept of a name itself. She anchored her entire internal network by creating this explicit structural link that essentially said, hey, this discrete tactile sequence is the name of this analog physical sensation.
Moving on to Section 4. Meaning from syntax.
All right, so we call this whole thing the cognitive transduction process.
Step 1, you receive raw, continuous input, like feeling that splash of water. Step 2, you quantize that raw sensation into discrete, low-entropy syntactic symbols. And Step 3, you form internal structural linkages between these completely uninterpreted variables. This right here is the semiotic bridge. It's literally how raw, chaotic feeling is captured and transformed into highly structured thought.
And this brilliantly illustrates how the pieces actually fit together. See, your sensory input gives you the concept node. The syntactic input, in this case the spelling, gives you the word node. But what about the semantics? Where does the actual meaning come from? Well, it's not beamed in from the outside world. The meaning is the naming relation node itself. Meaning gets generated the exact moment you internally align a syntactic symbol with a sensory concept.
Looking at Rappaport's fully partitioned semantic structure, he makes a really profound point. Meaning isn't some external substance that you somehow import into your brain. No, meaning is simply the structural position of a node within this massive internal web. To understand a concept just means having a sufficiently rich network of internal syntactic connections attached to it. The more links a node has, the more you understand it. It's exactly like a giant puzzle inside your head.
Finally, Section 5, Escaping the Room. So let's wrap up the key takeaways of syntactic semantics. First, we usually think of semantics as the relationship between a word and the real world. But under this theory, it's actually just the study of relations among internal symbols. Second, meaning is generated entirely by internal structural alignment. There's no external magic happening. And third, and this is a direct response to John Searle's paradox, syntax alone, as long as it's sufficiently complex and properly partitioned, absolutely suffices for semantics.
And here is why this deeply, deeply matters. Think about it. Helen Keller's brain never actually physically exited its closed room. Her deafness and her blindness remained. She didn't escape by magically reaching out into the world. She escaped by establishing an internal mapping. She built this incredibly robust architecture inside her mind that allowed her to generate profound, poetic meaning from completely uninterpreted tactile symbols. Her syntactic rewiring is what set her free.
Which leaves us with this final provocative thought. If our own profound semantic understanding of the universe is ultimately just a complex web of internal syntactic rules, are our minds really all that different from a machine's? Think about it. If Helen Keller could escape the Chinese room through syntactic partitioning alone, why couldn't a computer? I really hope this explainer has challenged the way you think about language, meaning, and the architecture of your own cognition. Thanks so much for hanging out with me today, and keep questioning how your own mind works.